test today?
Yeah, geometry is taking one.
Yeah, it was broken. He does
so casually. He does that every day. His hair is so thick he can do that.
I'm gonna try to give him a football helmet. I need like an XL just so I can fit him to his hair.
I like him. It's something different.
Did he play?
Yeah. Let's see, transfers to that like 30 days or whatever.
Oh. First try?
What do you mean 30 days?
I thought it was 90.
You know, people ask me on my voice.
90? You have 90 days. Once you transfer, you can't play varsity for 90 days. Because of recruiting issues. We have to be JV.
We got no quit.
Yeah, we do.
Okay.
Oh. Hey. Hey. For his birthday? I don't know. He was just like, I didn't get ready to something. I was like, what?
I thought it was. Is it up yet? Probably not that bad.
First try?
First try? What even is that? I hate those videos.
Try this out.
Like a Batman, like
hold it up to your eyes, Evan. It doesn't matter really.
Hold it up to your eyes.
This side. I know it's not just this side.
Yeah, she's like
Did you ever tell her that?
How do you find
like a diffraction.
She was so vulnerable.
Nope.
Honestly, it makes me mad that we didn't.
Like
new houses that are built today.
It's like everything you do is
What? Just put it up to your eyes.
That's so like
I was messing with
it came out of like a mini ball. It's used to diffract like red light or like green light from
Yeah, it's just called the concentration quiz.
Yeah, concentration.
Yeah, I only had like 30.
You only got 100 that's complete.
I really had.
Is this what it's like being young?
You didn't even know how you did anything. I had to teach you everything and then figured it out. And like it clicked in my head.
Jack.
That's serious. I just sent you an answer.
Your head is more clouded.
No, it clicked in my head.
All the fact that you went.
What did you just say?
I said your head is more clouded when you
All of a sudden it made sense.
because you asked questions like they
Blessed up, man.
I don't know why I did it.
Oh, not the
Like, I really don't think I did it.
Or the
Unless you've been feeling it, no. Because I wouldn't be able to do that game up to the straight
This is
door.
how I thought
That was
it
call and act like she knows me. And that was
was.
actually not as bad. Actually not as bad.
I can pretend for at least an hour. What?
She's really pretty.
No. Got it by a whole sheet. But in someone's windshield.
Oh, that's how you just.
I told Seth yesterday, like, I should try it like that.
Anything?
I always just thought that was the name of
You show up?
morning, and then after school, what was that?
Before school. I'm gonna look at it.
Because that makes sense now.
I can't even see words.
These are your testing.
If you flip it sideways, you can see the other side.
No, flip it.
Or
Like,
First try.
Whoa.
Tyler.
There's two Tylers.
Okay, John.
Are you not driving?
Not today. Well, mom's cars.
Sensor.
I feel like I'm looking right at T.O., right?
Yeah.
But he's
You're
over.
retaking it seriously.
you wouldn't
Jack.
But I should request the face next time.
Yeah.
And two. Okay.
All right.
Hey, did everyone get their test back? Everyone get one? Okay. All right. Those are yours to keep. If you're gonna choose who you take it, remember you have a week from what? That was Tuesday when I handed those out. So you have a week to decide if you're gonna do it. You show up in the morning. If you don't, I don't care. You don't get to retake. So that's how it works. So all right. So it's pretty straightforward. Today, we're just gonna go through a couple notes. We'll see where we get to. Monday we'll get homework on. Make sense? You have a weekend off for once. Okay. All right. But let's talk about the section we're in, which is P.6. So section P.6, which is called the rational expressions. All right, today we're going to try to continue on with where we left off on Thursday here. If you don't remember what we talked about yesterday, or maybe you're gone, we did the definition of what a rational expression is. Anyone remember the gist of it? What did we talk about?
Numbers and letters combined using basic operations for fraction.
Yeah, fraction form. He's quick. That's quick. All right, so yeah, so definition is that you're going to combine letters and numbers, basic operations, which we were talking about yesterday, but then had to be in fraction form. That's what the rational part is. That's if you write in fractions. The basic operations we discussed yesterday. We discussed the first three. Yep. So we did addition, subtraction, and multiplication. Subtraction and multiplication. Those are the main ones. If you can get these three, you can do division. That's easy. You can do division if you can get those three. Now, my question to you. Is there any particular type you'd like to see one more time, other than, like the issue here, but is there a certain type that you're not comfortable with first? Okay, so no one has a preference. All right, so my goal today is at least do one example of these leading up, because I really wanted to start with multiplication, but I'll try to do one example of each type. That way, when we get to multiplication, this will be a direct lead into what we're going to talk about today, which is division. This is the main one we need to discuss today. We have not discussed division yet. I know you discussed it in like Algebra 2, but not in here. So that's why I want to cover it. Then once we're done, the next type of problem that we're going to talk about is complex expressions. That's the part that I kind of hinted at yesterday, that these are probably the most difficult looking problems. They're not hard to actually simplify, they're just difficult looking. So we're going to try to discuss that. And then our goal today, before you leave, we don't have a lot of time for that, but I want to discuss where does this fit in the big scheme of things, which is limits in calculus. And I'll try to show you kind of an example of what I'm talking about with a limit. All right. So any questions right now about this problem? Okay, so let's do an addition subtraction problem. I'm just going to pick one from the book, just so you can kind of see what we're doing here. I think I have one kind of picked up that I want to see. We're going to do number 58. So 58. Read this off. 58, and we're on page 80 if you want to know where I'm getting these problems from. All right, read them.
6x squared plus 17x minus 40 over x squared plus x minus 20 plus 3 over x minus 4 minus 5x over x plus 5.
X plus 5?
Yes.
Like that? Okay, so this problem is mixing everything together. You're doing adding, subtracting, all in one problem. Remember what the rule was yesterday. When you add or subtract, you have to have common denominators. So that's what I'm going to do first. I'm going to, if I need to, I'm going to factor these apart, if I can, to figure out what all the different parentheses are on the bottom, if it's possible. Once I have it, then I can change the numerators. I can change what the top will be. That way we can go from there. And then after that, I should be able to add and subtract, things across, or all the way across the top. top. The denominator should not change if you add or subtract rational, even fractions in general. The denominator will stay the same. Okay? Any questions with what we're going to do on this problem? I just like it, kind of mixing both together. Okay, so let's first, we need to figure out this common denominator. So let's factor this thing apart. What rule do we use for factoring this denominator? Trinomial. The trinomial rule. There's no common factors here with these three items. So with a trinomial rule, the back symbol's a negative, so that means when I do my parentheses, I'm going to have plus minus. I'm going to break up the x squared to be x and x. Now I have to break up the 20 to be two numbers to multiply, give me 20. I have a couple options. But I need to get a 1 in the middle.
5 and 4.
5 and 4. All right. Any questions with how you factor that apart? I said, factoring is a big deal. That's why we spent so many days doing that. The top, I don't really care about it. In fact, I'm just going to leave it alone. Because it really doesn't matter if I factor that thing yet. I will factor it later. Okay. Anything I can do to this second fraction? Yeah. Right now it's completely factored, correct? But I need to get the common denominator. It looks like the common denominator between, because this thing factored apart is this. So when I look at all three denominators, it looks like these are the common denominators. This idea that using both parentheses is what I need to put on every single fraction because these are already factored. So it looks like the individual parentheses that I see are these two. So every fraction is going to get them. I'm going to have an x minus 4, x plus 5, and this last fraction will be x minus 4, x plus 5. All right. So does everyone see that how I pick the common denominator? I factored this thing apart, which was this, and then I can compare all three fractions to see what was the different parentheses that you get. If there's a term outside, those would be on every single one as well. That's how it works. So you have like a common factor that you pull out first. Yeah. Exactly. So if I change the fraction, this first one didn't change, it was factored apart. This one changed. I multiplied by an x plus 5, so I have to take the top x plus 5. Plus. Okay? The second one I took it times an x minus 4, so I have to take the top times x minus 4. So that's kind of the idea, right? That you're going to multiply by an x minus 4 or an x plus 5 to make sure that all the common denominators are the same. Now I can add the top together. You can go straight across, you can add. At the same time, you can distribute if you want. I'm not going to do that. I'm just going to write out what the answer is for this problem so far. So right now, if I add across, the denominator will not change. This is the denominator so far. Correct? Like that's the common thing that we have in all three fractions. So that will stay the same. But the top will be this huge mess, which is this thing. The 6x squared plus 17x minus 40. And then I'm going to have the plus 3 times the x plus 5. Most people do that in their head. And then I'm going to subtract the 5x x minus 4. Because that's that back fraction that I'm subtracting. Now, the only reason why I wrote that out, like why did I do that and not distribute, is because notice that back thing, the back item, the back fraction. It's a negative 5x times whatever's in that parentheses. So you have to distribute the negative sign. That's what some people tend to forget. Especially like right here, you distribute in your head, but then you forget the negative sign has to go with it. That's what some people tend to forget. Okay? But now, if I do this, I'm just going to replace these. This is a 3x plus 15. This is a negative 5x squared plus 20x plus a 20x. So that's distributing the negative 5x through that back parenthesis. So here's what I'm going to have. I'm going to kind of combine terms, put things next to each other. So I have the 6x squared minus the 5x squared. Those are going to move together. Those are the things on the top. The x's that I have in this problem are 17x's, 3x's, and the 20x's. So those are all the different x's that I see on the top. And then it looks like that minus 40 and the plus 15 are kind of grouped together. And then the bottom is always the same. All right, now most people can do that in their head. I'm just showing you like how I'm moving things together, where my terms are coming from. Am I missing anything so far? Looks like I got everything accounted for. Okay. So let's add these things together. Let's see what we get. We get x squared up front. So 1x squared. Oh, gee. does everyone understand how I got to this point? Is everyone kind of following with me? This you have to do if you add or subtract. At this point, if you didn't hear start, you do have to factor. The last step on an adding and subtracting problem is to simplify it. The hardest part is just getting it combined and getting to that item in the very end. But now, once you're here, you have to see if you can go further to see if this thing simplifies down. Okay, so simplifying this fraction, then you do have to try to factor the top part. So, geez, can I get a 40? Did I miss any negative signs or positive signs? Can I make a 40 with a 25? Is it 5 and 5, or I don't think that factors the part. 20 and 5 and 1. I believe that's it. All right, any questions with that problem? Let me double check the math. Did I get like a negative sign wrong?
No.
It looked like it, so. All right, there you go. That's not factoral. There's no way I can make the 40 in the middle using 25. There was a number up front of the x squared I possibly could have, but it doesn't look like it. Okay. Do we feel comfortable with an adding and subtracting problem? Now, on this problem, I know there's a couple of problems you're going to have in the beginning. If most of the first couple of problems you'll see on Monday, they're going to give you a problem that looks like this, and all they're going to ask you to do is simplify it. That's all the directions say. So just simplify the problem. So you try what you did here, where you try to factor the top part, try to factor the bottom, which this is already factored. You cross parentheses out that match, that type of thing. Don't cross out individual terms. You have to actually separate and then cross the full parentheses. Then I believe it asks you to write the domain of this thing. Domain are what numbers are you allowed to plug into this thing? That's a domain. So when you look at this problem, before I start canceling stuff out, there's a couple exceptions on numbers you are not allowed to use. Can anyone think of what the numbers would be? -5 and a +4. Why did you say that? You're right. These are the numbers you cannot use. Yeah, I think bottom 0. You can't divide by 0. It's just one of those things in math you're not allowed to do. It doesn't make sense. It's not, you can't calculate that. So the idea is that these are the exceptions. Now, what they want you to do is just to write you can write all real numbers except, or what I would do is I would just write this. X can be any numbers except cannot equal -5 or 4. That's fine. What we'll eventually do in chapter 1, we'll learn how to put this in interval notation. And that was the thing I think I hinted at the very beginning of the year when we talked about sets. That on interval notation it would be written like this: -infinity up to -5, skipping -5, going up to +4, skipping -4, +4, and going up to +infinity. And the parentheses just mean I skip this number, and they go in order least to greatest. And it would be every number leading up to these. So from here to here, this is all the numbers from -5 up to 4, but you can't use the outside numbers because they have parentheses. So that's something we will eventually learn in chapter 1. But for you guys, for now, this is okay. That's fine with me. All right. That's good practice. So he doesn't get comfortable with that. I believe the book and back of the thing. Okay. We're good with adding and subtracting. Let's try multiplication. Do something a little bit more difficult than this. Okay, now the multiplication problems that I hinted at yesterday, they have a different rule than adding and subtracting. Obviously, you don't do common denominators, right? So you're not going to do that. But they have a different starting point. You know, with adding and subtracting, you try to figure out the denominators and you fix the tops and you go straight across and you factor later. But on multiplication, you factor first. Factor everything first to see what cancels. So I'm going to do one of these problems. So I'm going to look at page 79. Problem we picked yesterday. Pick a problem that didn't do yesterday from these top. I don't know, did we do 22 yesterday? Really couldn't tell you. Okay. Right down.
Alright, x squared plus 6x plus 9 over
simplification problem. So we don't need to find common denominators. I know most people would attempt to like go across, multiply. That's how you technically multiply fractions. So you just go straight across. But the rule is the shortcut that I've learned over the years of doing this. Simplify it first. That way it makes the numbers all smaller and you factor it apart. That way you don't have to do as much for FOILing and other things and then trying to get down to your final answer later and factoring it back apart. So say it again. Cube rule is on the bottom, right? So cube rule is the small parentheses, big parentheses. So that's good. The top is a trinomial. And over here, that thing's already factored. I can't really do anything with that thing. I mean, that's factored as far as it goes. There's no common factors, and there's just a whole number on the top. All right, so on the top up here, the symbols are going to be the same. They're both going to be pluses. And it's going to be x and x, and then break them into 9 to make 6 in the middle is what, 3 and 3? I'll make the 6 in the middle. The bottom, the cube rule. The symbol here will stay the same. You take the cube root of x to the third, which is x, the cube root of 27, which is 3. And then in the back, the next symbol will be the opposite. The back symbol is always positive. This item here is made from these two now. So you square the x, that's x squared. The middle term is these two multiplied together. And the back item is this thing squared, which is 9. And this is guaranteed not to be able to be factored apart. It's just guaranteed by the way that cube rule works. Okay, now that we have this part, now I can start canceling stuff. How this works, what I first try to attempt to do is I cancel stuff top and bottom. Because that's obvious. Cancel stuff top and bottom. So x plus 3, x plus 3. 1 for 1. That's how it works. You don't cancel them all, just 1 for 1. Once you have that, then once you're done with going up and down, then what you attempt to do is you go diagonally. Because eventually these will be stacked on top of each other. So it doesn't matter the order you stack them. So now I'm going to go diagonally. So it looks like these are in common still. Yep. And your final answer now, if you go straight across, there's nothing left on the top except for the number 1. And the bottom looks like it's this, which is x squared minus 3x plus 9. All right. Any questions with this problem?
Okay, on the very first one, and Boyle, if we would have just multiplied directly across, we would have eventually got to the green.
Yes, you would have eventually got to the green, but that means you're going to have to like FOIL that thing together, right? Distribute it. The top you'd have to take times 1, and then at some point, once you had this thing down here, you'd have to factor it apart by using the grouping method, and that would have got you to basically this. And then eventually you start canceling stuff out. That's why when I do multiplication, I always simplify first. That way I don't have to do that crazy FOIL, crazy factoring, because I'm almost guaranteeing that somebody, if I were to actually multiply these out, multiply that bottom straight across, you get, x to the 4th plus 3x cubed plus 27x plus, what is that, 81? Multiply. There's going to be some people in this room that will not be able to factor that thing apart. It's grouping method. So you have to take out common factors, and you just basically get right back to where we were. That's the idea. So it'd be a grouping method and then a difference of squares. I would not want to do that, especially if it's more difficult than this. That's kind of an easy problem. That's why I always simplify it first. Easier and faster. Okay? All right. Now, there is exceptions on this problem. There's things that you are not allowed to do. Okay? For instance, I do not want this problem to be equal to 0. So if you're trying to figure out, what's your domain, it would basically be all real numbers except for you cannot use a -3 for sure. And even though they cancel out, you're still not allowed to use -3. That would still cause a problem in the original problem. Like right here. So you have to think about the original problem, and when you simplified it, anything that would make this thing 0, that would be a problem. Now, can anyone think of a number that would make that thing 0? So, plug in a 0, that'll be a 9. Well, it'll be a 1 9 because I plugged in 0 there. -9, is that what you said? -9, that'd be 80, positive 81. -9 would make that a positive 27, and then you'd add 9. No, that'd be a positive number. something we will eventually learn in this class. How you eventually find the answers for this thing. In fact, you already know how to make this thing 0. Quadratic equation. So it's x equals opposite of b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Like that's what we had a quadratic equation for. To figure out what would make that equal to 0. So this would actually be it's actually an imaginary number. Let me explain why. So it's a positive 3 plus or minus. This is what 9 minus a 36. That's 4 times 1 is 9. All over 2. And what happens here? You get a square root of a negative number. That's imaginary. So it looks like there's no way we can actually, since that's imaginary, there's no way this thing will ever be 0. That's what it's telling you. That's why it's imaginary. It will not happen. So really the only exception on this problem is this. That's something we are eventually going to learn in this class. Don't be like freaking out right now. Like we haven't even learned the rules of like why we use certain things yet. Right now you're just learning how to factor and multiply that whole thing. All right. Any questions, comments, concerns on some of the problems that we've talked about so far? If they ask you to prove the domain, that's what you do. All right, let's do a division problem. So why did I kind of prep you into doing adding, subtraction, multiplying? Now it leads directly to division. So I'm just going to do a very easy problem just so you can see division. So something like x squared minus 4 all over x squared minus 8x minus 20 divided by x minus 10, x plus 3. So something like that. All right, this is division problems. Division with fractions. So let me discuss what division is. Because like yesterday I was always prefacing like why do we have division? What are we using it for? So I'm going to go back to like one of the easiest problems you've ever seen, and then we can discuss it. So like 2/3 divided by 4/5. Right? You're taking a small number and you're dividing it into smaller piles. So you're gonna have like a ton of piles in this problem, right? It's weird. Dividing by it like a fraction makes things bigger sometimes because you're making them smaller piles so there's more of them. That's the idea. But what do you remember from Algebra 2 days? Reciprocal, that's the big one, right? Crisscross is kind of the idea, right? We're going to be crisscrossing here in a minute, but it's you do a reciprocal. You change this to a multiplication symbol, and then you do the reciprocal of the second number. You flip the second fraction. And say it again?
Why don't we just crisscross them instead of rewriting it?
Like going diagonally like this.
Yeah, like do 2 times 5 and then do the 3 times 4 to get 10, 12.
It's the same thing. I was just flip and go across.
Okay.
Okay. The reason why it'll make sense for this. That's what we did. So, but you're all right. So the idea is that you flip the second fraction over. You multiply now. Multiply. So that means if I'm going to multiply, you can go straight across, or you can simplify. Is there anything top and bottom I can simplify here? No. The diagonally I can, right? The 2 and 4 idea. Because now that we're done with up and down, you can go diagonally. So I'm going to simplify that to a 1, simplify this to a 2. Dividing both by 2, that's what I did. And now I can multiply across. And that would be the answer. Okay? Now, most people, they remember the rule. They remember from Algebra 2 days. They're like, okay, I understand. You got to flip, or you do the crisscross idea if you remember that. But they don't realize like where it originally came from. Okay? It actually, you know, if we go really, really far back to like elementary days, okay, this is where the reciprocal idea actually came from. You're taking 10 and dividing into 2, like 2 piles, right? Or this is the same thing as this. 10 times half. it's actually from. You're doing the reciprocal of the second number. This number is 2 over 1. So, I mean, this is literally the same thing. And that's why you flip it. And now I can go straight across 10 times the top divided by the bottom. That's where fractions actually originally come from. I mean, that idea of doing the reciprocal, then making the fraction from. All right. Any questions with like the idea of how the reciprocal idea works, the second fraction? We're going to do that for our problems and not doing the crisscross idea, which is correct. But doing this idea of reciprocals will help me on the problem I have in the middle of the board. Because I know I'm going to have to flip which fraction. Second, I know I'm going to have to flip it. So you can kind of see how this is going to work, right? So, let me get this problem. Okay, so on that problem, the first thing I'm going to do, right, I'm going to flip that second fraction. And when that happens, I'm going to switch this to multiplication. Okay. Any questions with how I just did that? Okay, flip the second one. Now, do you notice that this is now a multiplication problem, correct? So now you've got to follow the rules of multiplication. You have to get to this step first. You have to make it multiplication before you can do any other rules. Don't look at that problem originally and start trying to simplify it. Don't do that. Well, I don't even care. You need to make it a multiplication problem. Then you can follow the rules I showed you yesterday and just today about when you multiply. When you multiply, the first thing I always attempt to do is factor this thing apart. This fraction in the back, I can't do anything to it. So, I mean, it's literally just I have to leave it. This thing over here, the top is a difference of squares. So it's plus minus x and x, 2 and 2. Down here, it's 2 parentheses, because it's a trinomial. It's going to be plus minus. It's going to be x and x, and then it's going to be, what, 2 and 10? That'll give me the negative 8 in the middle. And now, I can try to simplify this thing down. So I would look, top down first. Over here, there's nothing. Over here, I do have the x plus 2s. And get rid of those. Now that I've done up and down, now I can go diagonal. Is there anything diagonal? X minus 10s. Those are gone. And so my final answer, if I go straight across, is just this. It's x minus 2 over x plus 3. Okay, remember, you have to get to multiplication before you go on. So really, division is multiplication. That's what you need to realize. These operations are the same operation. They work together. Same with adding and subtracting. They go pair and pair. Eventually, you're going to have to add the negative. All right. Now, here's my question to you. On that problem, what were the exceptions? What's my domain? What's my domain on this problem? Can't use a negative 2. What else? What else can I not use? Can't use a negative 3 or a 10. You can't use any of the original problem. So you have to look at the original problem here. If I factor this thing apart, that's x plus 2, x minus 10, so I can't use negative 2 and 10. And I can't use a negative 3. And even when I simplified it to here, when I flip things, I still couldn't use them. I know certain things canceled, but these are still an exception for the original problem as well as the new one in the very end. Okay, does that make sense now? You can use all those numbers except for those 3. They would cause a problem. If you were to actually graph this thing on a graphing calculator, if you had one, or you went on Google and you tried to graph it using the Chromebook, because Google can graph things, you'd notice that there would be like little holes right here. The graph would like go up to infinity, negative infinity at those random locations because they're exceptions. They cause problems. They cause errors. Some of these are called removable discontinuities. You can remove them from the problem. Like this 10 is removable. This negative 2 is removable. But on a graph, you'd still see there's a hole there. There's still a hole at negative 2. There's still a hole at 10, even though the graph might not show it. Especially on a Texas Instrument calculator, if you were to graph this, you'd be doing something up to -3, and -3 is where it really goes crazy because it was non-removable. So at -3, something big happens. It like either goes down to infinity and goes up to positive infinity. It goes like 2 different directions. It breaks. And then at at -2, there might just be a hole there. Might just be a hole at -2, and you may not even notice it. Maybe like super small in a graphing calculator. And same with 10 down the road. If this is 10, there might be just a hole there at 10. But you can't even notice it, especially when texting an instrument. Sometimes it just flows. You don't even notice there is a hole there. It causes an error. They just don't show you it because it was removable. All right. Any questions with the basic operation stuff? Okay. So now we needed all this. I've taken my time trying to show you all the little quirks and rules for this stuff. But the reason being is that you have to mix all of this together, everything, to do a complex. So the stuff that we've done seems easy. Like you get the rules. You'll be fine doing complex fractions. You will be fine, but I want to show you them. So let's do like 1 or 2 from my book. Okay? Maybe I'll just do 1 today, and that'll be my last example. Okay? We're not going to get to 1. Maybe we'll talk about it on Monday. No homework. So just give me 1 of these. So I don't care, just pick 1 of those. Okay? All right. So hold on. Okay. Fire away.
8 plus 1 over x
8 plus 1 over x.
over 4 minus 1 over x.
Is that it?
Yeah.
Okay, this will be my example. Okay? This is a complex fraction. Complex expression. The reason why it's got fractions over fractions. That's the idea. You probably remember these from algebra 2 days. There's different strategies that people teach you how to do these problems. Different ones. Okay? Some people believe very heavily that you need to add the fractions on the top because those are both fractions. You subtract the fractions on the bottom, and then you do the rule that I've been doing on the board. I'm a little bit different. I believe that if you multiply everything by a common denominator, all the fractions go away. And now it's nice and easy. Okay? So, when you look at this, look at this over 1, that's over 1, right? So look at, there's 4 fractions of it. You see them? Top left, top right, bottom left, bottom right. What's your common denominator for all 4 of them? 1 and an x. Does everyone see that? Those are the individual things you see. So what I'm going to do is I'm going to multiply everything by the number 1. Everything I'm nice. Why would I multiply by 1? Does it do anything to my problem? No. It keeps it the same, right? But instead of 1, I'm going to choose this. Is that your common denominator? What is 1x divided by 1x? 1. I'm still multiplying by the number 1. When I do that, when I multiply by a 1x, you have to actually distribute it. And distribute it. Because that's the correct way to multiply fractions. You go straight across. So when I do this, I'm taking the 1x times that. What's 1x times 8 divided by 1? So what's 1x times 8? 8x divided by the number 1? It's 8x. Right? That's fine. Fractions going. 1x times the number 1 divided by x. What's 1x times 1? 1x divided by an x? 1. Okay, so that's fractions going. On the bottom, 1x times a 4, which is the 1x times 4. 4x divided by the number 1. 4x. Okay? And a 1x times 1, 1x divided by x.
So then we'd be able to just crisscross this answer?
No.
Like, you know what I mean? Like the x times the 8 to get 8x.
Oh, like that?
Yeah.
It would be different if they had different denominators. So, because that's what we're going to have. Eventually, we're going to see like 4 different denominators. So we have to multiply by everything. So that's why. This strategy, what you're seeing here, is the fastest way I can teach you how to do this problem. It is the fastest way to do it. Now, what are the exceptions on this problem? What are the numbers you're not allowed to use for domain? 0. 0 is definitely an exception. You're not allowed to use 0. 0 caused the problem on the original thing, because that's 1 over 0. Can't do that. But on this problem, what would make this bottom 0? What would make 4x minus 1 equal 0? 4. You're not allowed to use a positive 4 fraction. You move the 1 over, divide by 4, so it's a 4. You're not allowed to use it. Our goal on Monday is to look at a lot of these. So you get good at them, so you're not scared of them, so you understand every quirky little rule. This strategy I showed you right now, by multiplying by that common denominator, works really well if the problem is really simple looking. That was simple looking. That's a strategy you can use. If it's complex, we'll get to those. And I'll show you how to do those next. All right. So you're done for the day.
Yeah.
No. You're what? Tell her that, see what she says. No. Exactly. Jonah, if it truly didn't work, you shouldn't have a problem with it, huh?
Well, I just egg fixed it.
Oh, alright. What?
Don't even.
What's that? Yes.
Stewie is in.
We'll pick them up. We'll pick them up. Yes. What time do they open?
Jonah can't, the rope is too heavy.
They open at. They open at like 9.
I think so.
I don't know
Yeah.
what this kid is.
Okay.
You need a heavyweight.
So I need to know, because that way we can tell.
Why?
I think Thursday morning should be fun. That way the bars aren't wilted, not dying.
See, here's the thing.
I'll sign you up.
The
Then
rope
go
is
up.
over 10 pounds.
Don't make Kate and Brady are doing it. Are they really?
What is that?
9.
Open at 9?
Me and Dad are doing it.
Alright.
Nobody knows.
I've done it every year.
Yeah, some of these are on Thursday. Yeah, because what I can do is I can skip.
My freshman year I went flying. Yeah, and everyone gave up.
Taylor, did you get your psychology done?
No.
That was like 2
Oh, yeah, I did it.
You know what?
Everyone was looking at the chart.
I just took a picture of the book.
Oh yeah.
Why is your
We had a test.
not nothing?
Yeah, I moved a couple of desks.
No, why is your